Welcome back to Explaining Everything, the channel where we break down the science and secrets behind everyday wonders. Today's topic comes from one of our awesome viewers, Chloe Star 123. Thanks for the suggestion, Chloe. You asked, how do airplanes stay in the sky? If you've ever looked up at a plane or flown in one yourself, you've probably wondered, how does something so heavy manage to stay up there? Well, today we're unraveling the incredible forces and engineering behind flight. From the magic of lift to the roll of engines, we're covering it all. So buckle up, because by the end of this video, you'll have a whole new appreciation for the science of flying, right here on Explaining Everything. Let's start with lift, the force that keeps an airplane from falling out of the sky. Lift happens because of the way air flows over the wings, which are specially designed to create an upward push. The shape of a wing, called an airfoil, is curved on top and flatter on the bottom. This shape forces air to move faster over the top and slower underneath. According to Bernoulli's principle, faster moving air creates lower pressure, while slower moving air creates higher pressure. This difference in pressure generates lift, pushing the plane upward. The pilot can also control the amount of lift by adjusting the angle of the wings. This is called the angle of attack. A slight upward tilt increases lift, but too much can cause the airflow to break down, leading to a stall. Lift wouldn't happen without thrust, the forward force that gets the plane moving through the air. Most airplanes rely on jet engines to generate thrust. Jet engines work by sucking in air, compressing it, mixing it with fuel, and igniting the mixture. This creates a powerful stream of exhaust that pushes the plane forward, kind of like blowing up a balloon and letting it go. For smaller planes with propellers, the spinning blades pull the aircraft forward by slicing through the air. No matter the type of engine, thrust ensures the plane moves fast enough for the wings to generate lift. Of course, there's also weight, the force of gravity pulling the airplane toward the ground. This includes everything from the structure of the plane to the passengers, luggage, and fuel. To stay in the sky, lift must overcome weight. That's why airplanes are built from lightweight but strong materials like aluminum and carbon composites. Every detail is carefully calculated to ensure the plane is light enough to fly, but durable enough to withstand the forces of flight. Finally, there's drag, the force that opposes the plane's motion through the air. Drag is caused by air resistance. Think of the wind pushing back when you stick your hand out of a moving car window. Airplane designers minimize drag by giving planes smooth, streamlined shapes. Everything from the nose to the wingtips is designed to help the plane cut through the air more efficiently. But here's the catch. Some drag is necessary. For example, the same airflow that generates lift also creates a bit of drag. It's a trade-off, and engineers work hard to find the perfect balance between reducing drag and maximizing performance. So how do these forces work together? Imagine a tug-of-war happening in the sky. Lift pulls up while weight pulls down, and thrust pushes forward while drag holds back. When the plane is cruising at a steady altitude and speed, these forces are balanced. During takeoff, the engines produce extra thrust to overcome drag and generate enough lift to leave the ground. During landing, the reverse happens. Thrust is reduced, and drag is used to slow the plane down safely. Staying in the sky is one thing, but steering and keeping the plane stable are just as important. Pilots use special control surfaces to maneuver the plane. First, ailerons on the wings, control roll, tilting the plane from side to side. Second, rudders on the tail, manage yaw or side-to-side direction. Third, elevators on the tail, adjust pitch, raising or lowering the nose of the plane. These controls allow the pilot to make smooth turns, climb higher, or descend, ensuring the flight stays on course. One common question is, what happens if the engines fail? Surprisingly, planes don't just drop out of the sky. Thanks to their wings, airplanes can glide for a significant distance, even without engine power. Pilots are trained to handle these situations and guide the plane safely to the ground. So how do airplanes stay in the sky? It's all about the perfect interplay of lift, thrust, weight, and drag. Wings create lift. Engines provide thrust. Weight keeps gravity in check. And drag reminds us that air isn't as empty as it seems. The next time you're on a flight, take a moment to marvel at the incredible science and engineering that makes it all possible. Airplanes are more than just machines. They're a testament to human curiosity and ingenuity. Thank you for watching. If you enjoyed this breakdown, be sure to like this video and subscribe for more amazing explanations. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.